Let's solve the problems on Z transform. So we have seen the Z transform properties in the last video, and we'll go for solving the problems on the properties of Z transform in this lecture. So we have the various properties like linearity, the time shift, convolution, then differentiation in the Z domain, so on. These properties are applied and the problems are made bit simple. So let's see those problems. Let's see the problem x of n is equal to n into minus of half raised to n u of n and convolution of 1 by 4 raised to minus n u of minus n. Now this problem we have to solve by means of properties, and to solve this one we should know that this minus of half raised to n u of n is one signal, and this is, if we can think that this as one signal, then n into, we can consider this one as x1 of n and n into x1 of n, means by using the differentiation property, that is n into x of n is equal to minus z d by dz of x of z, we need to find. And even this one, by using the time reversal property, we have to solve this. So let's see how this happens. So we consider this signal first. So that is minus of half raised to n u of n. When we consider this minus of half raised to n u of n, let's take this, and it's z transform by our knowledge, because alpha raised to n u of n's z transform is z divided by z minus alpha. So similarly, by using that z divided by z minus, we need to write this value, which will be minus of 1 by 2, which makes it as plus. So I hope no problem in knowing this. So the z transform of only this part, minus of 1 by 2 raised to n u of n, is this much. And certainly we write this expression by considering that it is a right-handed sequence when z is greater than alpha is the condition for that. Now alpha is 1 by 2, so as z is greater than 1 by 2. Now, so once we know this, let's name it as x1 of n, then n into x1 of n. So n into minus of 1 by 2 raised to n u of n's z transform we need to find. So it is n into minus of 1 by 2 raised to n u of n, so which is w of z is equal to, so the formula is minus z d by dz of x of z. Now for this, x of z would be this much, so it is z by z plus 1 by 2. So we go for differentiating this one. So the differentiation of this by u by v rule, so it is this much divided by this much. So, and we write this as it is, differentiation of, we write this as it is, differentiation of z is 1, so we get this as it is. And now we need to write this z as it is, and differentiation of this z plus 1 by 2 is again 1. So we get this much, so which is the z transform of n into minus of 1 by 2 raised to n u of n. Now the next thing is, we need to find the z transform of the next thing, that is 1 by 4 raised to n u of n. So that is, but it is with the minus sign, but initially we find the z transform of 1 by 4 raised to n u of minus n. Then it would be 1 by 4 raised to n u of n. So 1 by 4 raised to n u of n's z transform is z divided by z minus 1 by 4. So once we have this, we consider it as x of n's z transform is x of z. But in our problem, we have minus n at these places. Then if z transform of x of n is x of z, then z transform of x of minus n is x of 1 by z. So by using that condition, to know the z transform of 1 by 4 raised to minus n into u of minus n, we need to replace z by 1 by z in our equation, in the solution. So when we write this z as 1 by z and substitute in this equation, we get this kind of equation which gives us minus of 4 z minus 4. So and we write this with a condition that it is a right-handed sequence, so z is greater than 1 by 4, and when we put 1 by z, then it makes it as z less than 4. Now convolution is nothing but multiplication in the z domain. So w of z we know in the last one. So w of z is this much minus of 1 by 2z, z plus 1 by 2 square, and the second one is this one. So we get 2z, z minus 4, z plus 1 by 2, the square. So once the multiplication happens, we get this result. Let's see a problem. N multiplied by n minus 1 into a raised to n into u of n. Then how can we go for solving this problem? So first we'll multiply this one. It is n square minus n, a raised to n u of n. So we'll take this multiplication individually. So n square into this value a raised to n u of n, and with a minus sign n into a raised to n u of n. We know that the z transform of a raised to n into u of n is equal to, just like alpha raised to n u of n's z transform is 1 by 1 minus alpha z raised to minus 1. Similarly, for a it is 1 by 1 minus a z raised to minus 1. Then for n into a raised to n u of n, by using the time domain, the differentiation property says that n into x of n is nothing but minus z d by dz of x of z. So by using that, now our x of n is a raised to n u of n, and n into x of n becomes minus z d by dz of this x of z. So which will be given by minus z d by dz of 1 by 1 minus a into z raised to minus 1. So we go for differentiation of this one. We may take this one as z by 1, z by z minus a, or we can go in this form. So one can differentiate this equation and go for finding the values. So we get a into z raised to minus 1, 1 minus a into z raised to minus 1, the whole square. So this z transform, this value will be equal to a into z raised to minus 1 divided by 1 minus a into z raised to minus 1, the whole square. Then for the second term, that is for this term, n square a raised to n into u of n, again we need to go for differentiation, because n square is nothing but n into n. So already we know n into a raised to n u of n's differentiation. So one more times we need to find the differentiation. So minus z d by dz of now this differentiated version. So when we do this, we get 2a square z raised to minus 2, 1 minus a into z raised to minus 1, the whole cube. Now let's see another problem, that is x of n is equal to n square half raised to n into u of n minus 3. How can we go for solving this problem? Now here we have u of n minus 3. So in order to have this, first thing in solving these kind of problems by using the z transform properties is we should have the same nature of n. I mean, if u of n minus 3 is there, we should have this half raised to n minus 3 and so on. So for that we adjust this and we write it in this fashion. So this 1 by 2 raised to n is written as 1 by 2 raised to n minus 3, and 1 by 2 raised to 3 is taken outside. So we write n square 1 by 2 raised to n minus 3 and u of n minus 3. So the same can be written as it is 1 by 8 n square 1 by 2 raised to n minus 3 u of n minus 3. So let's solve this problem. Here we'll think that this half raised to n minus 3 into u of n minus 3 as our x of n. So we consider that this is equal to x of n. So we have n square into x of n is this all divided by 8. So this z transform of this one. So let's treat it as x1 of n. So we find the z transform of this. So in order to find the z transform of this x1 of n, we need to know what is the z transform of 1 by 2 raised to n u of n. So we find 1 by 2 raised to n into u of n's z transform. 1 by 2 raised to n into u of n's z transform. So the z transform of this is equal to, it is 1 by 1 minus z transform of this is equal to 1 by 1 minus 1 divided by 2 into z raised to minus 1. So it is just like alpha raised to n, u of n's z transform is 1 by 1 minus alpha into z raised to minus 1, and when we simplify this one, it becomes z divided by z minus half. So we know that the z transform of 1 by 2 raised to n u of n is z by z minus half, where this z is with the ROC condition that when our z is greater than 1 by 2. So now we use this. So likewise we need the z transform of 1 by 2 into u, but the shifted version is there. Now here it is u of n minus 3, and it is, so this is u of n minus 3, and even this is n minus 3. So by using the time shift property, the time shift property states that x of n minus n naught, x of n minus n naught is equal to z raised to minus n naught into x of z, where x of z is the z transform of x of n. Now here this we are considering as our x1 of n, and the x1 of n's z transform is, this is x1 of z. So it is x1 of z. So when we go for 1 by 2 raised to n minus 3, u of n minus 3 is the z transform, then simply we get the same thing like it is supposed to be z divided by z minus 1 by 2, which is x1 of z, but this has to be multiplied with the z. So let's write it in this fashion. So it is z raised to minus 3 into x of z. So as it is z raised to minus 3 into x of z, we can write this one as x1 of z for this, because this all we have considered as x1. So we have taken this one as x1 of n. So we can write this as it is x1 of z. So we could write this as z raised to minus 3 into x1 of z, which is z into, it is z into z divided by minus z minus 1 by 2. So when we simplify this becomes z raised to minus 2. This becomes z raised to minus 2. So this is z raised to minus 2, z divided by 1 by 2. So we can write this one as, we can take z outside, and so which can be written as z raised to minus 3, 1 minus 1 by 2 z. Or from this we can write it is z cube divided by 1 minus 1 by 2 z raised to minus 1. Now we don't have simply this much. There is n square into x1 of n, and there is a constant divided by 8 also. Then we need to go for finding that. So we can add this 8 later. So n square would be minus of z d by dz, means n into x1 of n has to be found like by double differentiation, and in order to do that we need to go for two times differentiation. So it is minus z d by dz of, again minus z d by dz of minus z d by dz of this value, which is differentiation of x1 of n, which is nothing but z raised to minus 3 divided by 1 minus 1 by 2 into z raised to minus 1. So in order to find this, first we need to find the differentiation of this value, again multiply with minus z, and again this will give us n square into x1 of n's z transform. Let's solve this. So after solving this, we'll get 3 z raised to minus 3 minus z raised to minus 4 divided by 1 minus 1 by 2 z raised to minus 1 the square. Now n square x of n z transform is again the differentiation of this. So we go for differentiation of this one, minus z into whatever is the result of this. So 1 minus 1 by 2 z raised to minus 1, the square is there already. So it goes to 1 minus 1 by 2 into z raised to minus 1, the raised to, this raised to 4, into this value, differentiation of this, again minus of this value into differentiation of those multiplied by minus z and divided by 8 will be the z transform of this value, that is n square into, that is this one, z square x of n square half raised to n u of n minus 3 z transform is to be found in that fashion. So even we can see the simpler problems of this kind. So I hope one can solve these kind of problems, and the further things, if any confusions are there, we can see in the next videos.